This is the cabbage colours experiment. Now, cabbage colours needs a cabbage, no surprise there. We do need a red cabbage for this experiment, okay, so red cabbage, because we're going to be needing some red cabbage juice from this particular experiment. Now, there are two parts to this experiment. First of all, we've got to prepare and make up the red cabbage juice, and then we're going to use that in an experiment. And on the table in front of me, I've actually divided my desk slightly over, so I've got all the bits I need here, plus there to make the cabbage juice, or almost all the bits, and the stuff over here we're going to be using for the final experiment, okay? Now, I would probably recommend that the very least you do in the kitchen is preparing all this stuff, because this is cooking. You could probably do it all in the kitchen, it's good fun anyway. So doing it in the kitchen, of course, means it's easier to wipe up afterwards if you make a bit of a mess, even with this bit, which can get a bit messy, as you're going to find out. So let me first take you through one way of making the cabbage juice. There's more than one way, but this is the way I tend to do it when I make mine. So red cabbage, knife, obviously be very sensible if you're going to do this. This is a sharp knife, be sensible. Some people just pull all the leaves off like that, and that's fine, that works too. But I tend to slice mine, okay? So slicing it up. Now, while I'm doing this, I would mention there are a couple of other ways. So for example, some people do exactly what I'm doing. They get all the bits and put it into a microwave. So that's another way of doing it. Now let's use what I've got so far just to show you what I mean here. Some people just use their fingers and break it up. Now I'm going to put the fragments in this pan here, okay? I'll leave that there a bit and cut it up. You haven't got to be particularly fanatical about this, just break it up into smaller bits. What we want to do in a minute is cook this so we can get all the juice out that's inside here, okay? So just break it up into little fragments. And as I say, there's no reason you shouldn't use your fingers if you're strong enough to tear it, but try and get fairly small size fragments, okay? Now what I want you to do is make at least, if you're an adult, a big fistful, at least that much. If you're using a pan about this size, maybe about half full, okay, about half full. So, but in my case, as you can see, I've got a good strong handful there, but I'd recommend possibly a little bit more. Once you've got that much, then you need some water, okay, and I'm going to just pour the water from this bottle. You can do this under a tap, of course, if you're in the kitchen, and just pour enough water in so it covers it. You don't want it really deep, just so the water is just covering the leaves that you've got in there, and that'll be fine, okay? Then what I want you to do is take that, put it on a cooker, and again, please be sensible with this. I want adult help definitely with this one. So put it on a cooker and heat it up. Watch it at all times, I recommend. Heat it up until it boils. That'll only take a couple of minutes. And then once it starts boiling furiously, lots of bubbles, I want you to turn it right down just so it's just gently bubbling. Every now and again you see a bubble popping out. So very gentle, what we call a simmer, very gentle simmer for about 20 minutes, okay? You shouldn't need to add any water to that because we don't actually need very much for this experiment anyway. So simmer it about 20 minutes, okay? Now, of course, we don't have time to do that. So I'm going to move this right out of the way because we did actually do one earlier. Because what you're going to need to do is once you've done this, you've simmered it for 20 minutes and you need to switch it off and let it cool right down, okay? Now that's obviously going to take quite a while. It could be an hour or so depending on a few things. So let it cool right down, okay? I did actually cook a little bit more, as you can see. But you see some of the water seems to have disappeared. It's actually there, but we can see it. Next thing we need is get the cabbage juice itself, because that's the bit I want for this experiment. Now what I'm going to use here is a metal sieve. You can use a colander, that's okay, but a sieve's fine usually. Make sure your pot underneath is big enough to sort of pour that. And I'm just going to pour the cabbage through here so I can sieve out and just get the liquid itself, okay? Make sure the pot underneath is nice and clean, please. So just pour it in. And I've got loads here, I've got more than I need, but that's okay. And if you're feeling a bit peckish, you could probably eat the leaves if you like. They're totally safe. People put them in salads and stuff, don't they? Don't think it tastes too bad. Okay, so I'm happy with that. Once you've done that, we've finished with the leaves. As I say, go and chuck them in a salad. So in here, now we have the juice. It's going to be a bit awkward for me to pour from this, so what I'm actually going to do is pour it into a measuring jug. Okay, and also that's useful when you do your experiment because you may want to measure exactly how much you're using. Now I should be able to pour straight in. I was going to use that earlier, but I don't think I need it. So just pour straight in. And that's plenty for what I'm going to show you now. You don't need anywhere near that amount. I've got plenty left, but that's good because there may be some other things you might want to do, which we'll talk about afterwards. So I'm going to move this out of the way just for a minute. So we've done the bit where we needed to prepare the cabbage juice. Remember, we chopped the cabbage up, we heated it up, we've got the cabbage juice. Here I have 2 glasses, 2 pint glasses. I would rather you didn't use glass. I recommend using big containers if you can get them, but smaller ones will be okay. I'm using these bigger ones because I want to show you what's happening in a particular way, and I'm using glass so you can see what's going on inside, okay? You can get big plastic cups, of course, that's no problem, just get see-through plastic ones. Over here, I have in this bottle clear vinegar. So this is distilled vinegar, clear vinegar, okay? I'm going to pour some in there in a minute. This is just tap water in a little bottle, just ordinary tap water, okay? The powder here is baking soda, bicarbonate of soda. Now, this is actually an acid-base indicator experiment. We're going to compare acid and bases. Another word for base is alkali. When we put a base into liquid, it becomes an alkali, okay? So acid-alkali experiment. And we're going to see if I can show you how we can use cabbage juice to tell the difference, okay? So I'm going to pour some in here first. Now the measurement I suggest you use initially is somewhere between 50 and 75 millilitres. In both cases. I'm going to do this by eye. I'm not actually going to measure it exactly, but I'd like you to do that. Remember, scientists usually measure things if we can, but I'm just going to do this by eye because I'm demonstrating it to you now. So roughly, when you do it, 50 to 75 millilitres. But I'm happy enough with that now, okay? And remember, this is the vinegar. I better check. Yep, definitely the vinegar. Remember, if you're not quite sure what something is, you never drink it. Sniffing it's usually okay when it's a household thing like in the kitchen. Okay, now, this one I'm going to pour the water in. Now I want to pour about the same amount. I'm going to duck down so I can see what I'm doing. I'm going to line them up side by side because I want about the same amount in each. Doesn't have to be exact from my point of view. When you do it, try and make sure they're the same, okay? Okay, that'll do. I'm happy enough with that. So that was the water. Now, vinegar is an acid. Okay, it's an acid. If you want to know the technical details, it's got a pH of roughly 4. Now the acid scale goes from 0 up to about 7 or just under, and then the alkali or base goes from 7 up to 14. So the whole lot is 0 to 14, okay? So this is on the acid end, it's about pH 4. We're going to make stuff which is about pH 10, so this is what we call an alkali, and baking soda will do that for us. Now what I need is just a teaspoon, full teaspoon, and I'm going to dump it in there like that. Okay, now it doesn't really dissolve in water, so what I'm going to do in a minute, I'm going to redo this, but I'm going to agitate it, stir it around in other words, so that it gets in a sort of a suspension, all the little particles of baking soda are floating around in the water. And remember, this is bicarbonate of soda, and bicarbonate of soda is a base, so we can turn it into an alkali by putting it in water. So let's see what happens with the colours, because that's where I like this one. Remember, this is called cabbage colours. So, hopefully you're up with me so far. Not too complicated really, is it? This is what I want you to do. First of all, I want you to get your cabbage juice and pour about 50 millilitres into the clear vinegar, assuming you've used the measurements I told you, about 50 millilitres, right? And then I want you to pour about the same amount, 50 millilitres, into that one. Before you do, just give it a little stir though. Give it a little stir because that can help things. And while it's moving around, pour in the same amount. Notice what you notice. Then, I want you to get both of them together, but before you do, get a bucket or a bowl or go to the sink for the next bit. I don't have a sink nearby, but I do have a bowl. And what I want you to do, once you've got the 2 glasses, pour one into the other, Doesn't matter which you pour into which, just do one into the other and make sure, please, you hold it over your sink or bucket or bowl. Away you go. Well, let's see what happens when I did it. I hope you found the same thing. So remember, I'm doing this by eye, so you're going to do it by proper measurements, being proper scientists that you are. So here we have, pour a bit more in, a red colour, very clearly red, isn't it? Beautiful red, actually. I love the way that goes, that colour actually, when you pour the colouring into vinegar. It's very similar, in fact darker than the red on my jacket, isn't it? Beautiful colour, beautiful clear red. So whenever we pour it in, it should do that. Right, remember the other one? And again, I did this by eye, so obviously I'm just estimating how much, but I'm going to do my best to pour about the same amount. Interesting, isn't it? Very different colour, sort of a deep bluey green colour. Actually, if I put it side by side here, and I'm going to duck down and check the measurements. Yeah, they're still about the same, so that suggests I did actually put the same amount in each, doesn't it? They started off about the same, they've gone up about the same, so it means I must have put about the same in each. That's a good test there. But notice the colour change. Red, deep bluey green here. Hope you found the same thing. But remember the last bit. This is where possibly you had the most fun. Let me get the bowl back. Because I said I want you to pour one into the other. I think I'm just going to pour the acid into the alkali and let's see what happens, okay? Watch very carefully. So what's going on? What's happening here when all these things happen? Well, there's a couple of different things, remember? Let's first talk about why they changed colour, right? So we had, remember, the vinegar in this glass, the baking soda and water in this one, acid in this one, alkali in this one. Turns out that red cabbage juice, we can use it as an acid-base indicator. Turns out that when you pour red cabbage juice into acids, particularly if it's quite acidy, a low number, 2, 3, 4 pH, remember this is pH 4. pH, by the way, stands for potential of hydrogen. I've got to remember that, just telling you, pH, potential of hydrogen. When we pour this into an acid, it goes red, okay? When you pour it in something that's very alkaline, the other way, as you saw, it went that deep bluey green colour. So straight away, just by the colours alone, if I didn't even know what I'd put in those glasses, if you'd done it, brought it in front of me, if I'd had some cabbage juice with me, even without you telling me, I could have poured that in one. If it had gone red, I could have said, that must be an acid because it's gone red. That one must be an alkali because it went deep bluey green. Okay, and I could probably even give you an idea of how acidy or how alkaline it was by the colour itself. Okay. What happened when you poured them in together? Well, essentially what we did, we neutralised them. When you pour acid and alkali back together again, they cancel each other out in a way. That's one way of thinking about it. They cancel each other out. And in the process of doing that, this neutralising, cancelling out, lots of gas is given off. And you saw all those tons of bubbles coming up. And that's carbon dioxide gas. So you heard it fizz, you saw a whoosh of bubbles and foam coming out of the glass. That's the carbon dioxide gas that's been given off in the reaction between an acid and an alkali. And that usually happens in this way, okay? One other little thing. Notice the colour it's gone to now. Now if I hold the cabbage juice up, it's quite similar to the cabbage juice. Remember, that was the mixture we made after, the foamy mixture. We've got a little bit of liquid left. It's gone back to a similar colour to the cabbage juice. So that suggests to us that it's gone back to the same level of acid or base as this, because the colour's the same. So if it makes the same colour, it's probably got the same level of acid or base in it. Now it turns out that cabbage juice is what we call neutral. It's about pH 7, it's right in the middle. Do you remember the limits I said? Most acid is 0, most alkaline is 14, so bang in the middle is 7. That is about 7. And things in the middle go that colour. So if we pour cabbage juice into anything that's about 7, neutral, it will go that colour. So tap water usually is about 7, depends on what part of the country you've got it from, but usually it's about 7, and you can pour it into it and go the same colour. So we have an acid-base indicator using an everyday object. So what variables could you try to see what's going to happen? Well, hopefully you've had a few ideas straight away. I've just used 2 particular liquids, haven't I? I used an acid and a base, or an alkali, which you can easily get from around the house. So straight away you're probably thinking, hang on a minute, well, I can probably get some other liquids from around the house I can try. Brilliant idea. Please be careful with what you're using, because some substances that people keep in their kitchens under the sink for cleaning are a bit dangerous, so you must check before you use them. Make sure you check this with a grown-up. But whatever you use, try a selection of household liquids. One way I suggest you do it is maybe get a little row of plastic cups, however many liquids you've got, get that same many cups, pour a little bit of liquid, of that household liquid into one cup, get another liquid, another liquid, another liquid, have a big batch of cabbage juice, and go along and pour a bit of cabbage juice into each and see what colour it goes. I'll give you a couple of clues of what you might find. Again, I don't want to tell you much because I want you to do it yourself. Lemon juice. Lemon juice is interesting. Lemon juice is actually 10 times more acidy than vinegar. And on a pH scale, remember I told you vinegar was pH 4? Lemon juice is about pH 3. So one number difference is actually 10 times more. And the smaller the number, the more acid it is. So pH 4 for vinegar, pH 3 for lemon juice. But lemon juice isn't clear. Lemon juice has got sort of a yellowy look to it. But what you'll find is it will go red, but it won't look quite as red as that did. I won't say any more than that. Other things you could use are things like people use to clean the bath, say, or clues to clean the sink. Again, be careful because some of those chemicals are a bit dangerous. Please, please ask a grown-up to do this with you. And you might want to wear kitchen gloves as well. You could wear kitchen gloves for all of this anyway to stop stuff getting all over your hands. But try those as well, and you will see they will go different colours. Of course, you could try obvious things like milk and water and tea and maybe other fruit juices, orange juice, that's worth trying. But I'll leave you to figure out a few more. Over to you.